Go.
Amazing.
All right. Good afternoon, everybody. Welcome. This is Corey Gabriel, the Executive Director of Climate Science and Policy at Scripps Institution of Oceanography in beautiful and perpetually sunny La Jolla, California. We are not here to talk about great weather today. We're here to talk about a really serious weather event that's starting to take shape in the Gulf of Mexico, Hurricane Michael. It is a strong Category 2 hurricane. The latest advisory we have up here from 2 p.m. from the National Hurricane Center, 2 p.m. East Coast time, 11 a.m. out here, 1 p.m. in the central, which is where the hurricane is. That's why you see that. Moving north at 12 miles per hour. Right now, the storm is strengthening. Its central pressure is 965 millibars. That's down from about 975 millibars yesterday. And to give that some context, what that means is basically the storm is about a 10 to 15 to 20 miles per hour wind stronger in the center. So this storm is expected to continue a strengthening trend, which is quite unusual, as we'll discuss later, into the Gulf of Mexico, and we see a very narrow cone of uncertainty here, and that's what we call this area where the National Hurricane Center expects the storm to stay. We're very confident in a landfall between Apalachicola, Florida, and Panama City, Florida tomorrow around this time, maybe a little bit earlier. So, looking back at the history of this storm over the last 3 days, you see Michael was a relatively disorganized storm with all of its thunderstorms focused on the right side down by the Yucatan Peninsula and then passing over Cuba, taking in all that dry air. But now the storm has emerged into a very, very favorable environment, and you see very strong thunderstorms located around the center. And you can even see in this infrared picture here an eye starting to develop. And you can see that eye even better in this really visually stunning geostationary satellite, meaning the satellite's sitting right over it, image of the Gulf of Mexico, where you see a very well-developed or relatively well-developed eye that you see is going to start to develop even more. One feature about this storm that was interesting is it didn't really have a distinct eye wall until the last couple frames, but as that westerly wind shear, that wind coming in and blowing the cloud tops off of the center, has diminished, we've seen a real increase in the amount of warm air secluded around the center of that storm. We're seeing that storm exhale better, and as that wind shear is diminishing, we're seeing we have a very well-developed hurricane. You've seen this before. These are called spaghetti plots. What you probably haven't seen is this kind of agreement. 24 hours out of work, hurricane is in a hit. Every single model that initialized correctly seems to put the storm in a landfall somewhere between Destin, Florida, and Apalachicola, Florida, which is about 50 to 75 miles wide. So for this far out, we have a very good idea of where this storm is going to go, and we know why. What we have in the next frame is an image of planet Earth, of the northern hemisphere, of North America actually, at 500 millibars, which corresponds to 5 kilometers up in the atmosphere. And why do we show winds at that height? That's where weather happens. That's where weather moves. What we see here is the storm is like a cork in a stream. It's right between the subtropical high, aka the Bermuda High to the east, which is centered off the coast of New Jersey right now. And you see a big dip in the jet stream coming in across California and into the plains down into Mexico, and then moving up with north winds across the Midwest. And this storm is stuck right in between those two features, and it's going to continue to progress and move up right between these two features. And you see tomorrow at this time, right at landfall, you see the storm is starting to be influenced more by that trough coming into the west, which is also starting to lift up, which is reducing wind shear. So there's nothing to really reduce the strength of this storm as it makes landfall along the Gulf Coast of Florida. So speaking of that landfall, we have here a population map of Florida, and these red areas are very populated areas. So you see we're very lucky the storm is not making landfall in the Tampa area because it's a very populated area. But the storm is likely to make landfall somewhere between Panama City and Apalachicola, and the Panama City area is pretty highly populated. But the worst impacts will be to the east of where the storm makes landfall in terms of storm surge. So if there's some silver lining here, it's that the storm is making landfall in a relatively unpopulated area. We see the most affected storm surge area is 8 to 12 feet, which corresponds to a Category 3 hurricane, all relatively unpopulated areas. This is unusual for this reason. What you see here is the result of a paper published in Nature in 2017 by Cosin, which shows a buffer zone around the U.S., meaning if there is a year where there is a lot of strong hurricanes, There are often conditions near the coast where there are strong wind shear, like I talked about, and abnormally cold water. And what this does is this makes it so if you have a storm like where Michael is right now, you expect it to weaken as it enters this buffer zone. That's not going to happen this time. Every single intensity model is showing this hit at very least a very strong Category 2 hurricane. Most is a Cat 3, some even as a weak Cat 4. The buffer zone conditions don't apply. First thing I'm going to show you, and stick with me on this one, right now look at this bottom right panel. This is right now. You see all of that red near the storm. That's wind shear. That's bad for the storm. You see 24 hours forward at landfall, back to this bottom left panel, wind shear gone. Storm will be able to intensify if other conditions are right. What's that other condition we need? Warm water. What we have here is a visualization of sea surface temperature anomalies in the Gulf of Mexico. You see everywhere between this storm and where it's going to make landfall, we are at least 1.5, and in some cases about 3 Fahrenheit above normal. Why is that? Just chance. No cold front has made it into the Gulf of Mexico this year, so no cold air, no upwelling, so that water is just abnormally warm by chance. So the storm is going to enter that area, weak wind shear, warm water, so conditions favorable for strengthening. And you see this trend happening already. This is like a before and after. Here's an IR picture, infrared picture of the storm about 12 hours ago, and then an after now, maybe a couple hours ago. You see that eye developing, much more developed storm. Only a couple more images to get through. You've seen this one already. Again, this is our storm right now. Absolutely incredibly well developed, and look for a storm that looks a lot like this to be impacting the coast of Florida within 24 hours. A couple more things to get through. This is probably the most important picture I'm going to show you. This is a high resolution model initialized within the last 8 hours or so, which shows a close-up of the storm making landfall at 947 millibars, which is a Category 3, very strong, to a Category 4 storm. And you see the wind bar here. You see winds sustained on this model of 110 miles an hour impacting Panama City Wednesday morning and early Wednesday afternoon, with a landfall here in Destin, Florida, worst impacts near Panama City. Just a devastating event for Panama City. 1985 Hurricane Kate comes to mind as an area that struck this area, a storm that struck this area at this strength. So this is a very unusual event. A couple more things to wrap up. You see here, this is from the National Hurricane Center. This shows that many, many people all the way up into Georgia are going to be impacted by tropical storm force winds between now and 48 hours from now. So it's going to be a very large area, and there are a lot of trees in this area, so look for a lot of power outages to occur in Georgia and Tallahassee. Tallahassee is a city that has more trees than really any other city I've ever seen, and it's right in the path of where some of the strongest winds might be here. So that might be part of the story here, trying to restore power to a pretty big metro area there. Last slide I'm going to show you is a radar loop of this storm coming up into the northeast. You see, at first, it's a well wrapped up hurricane with a central eye really spinning around a center. But as it hits land and it interacts with the colder air coming down out of Canada, that rainfall, instead of being centered around the storm, is going to kind of shift to the back end, to the west side of the storm as that cold air moves in. So look for some of these models to be maybe underdo some of how heavy the rain could be over central North Carolina, because the models often miss the mechanism when these storms start to transfer and cold air starts to come in. So look for more rain than's currently being forecasted over parts of North Carolina. So again, main impacts here: storm surge, inland winds, winds at the coast. Rain, not as much. Yeah, 10 inches of rain where the storm makes landfall, 4 to 6 inches of rain well inland. But the main impact here, wind, storm surge. If you're under evacuation orders in Florida, on the panhandle right now, take those very seriously. The circumstances here are very different. Intensifying hurricanes are a very, very big deal. Take this one seriously. Don't ride it out. Get out. Be safe. Thanks a lot, everybody.